Okay, well, good evening and welcome to the North Jersey Astronomical Group. We're going to get started with the April meeting here. Tonight we have a very special guest speaker. We'll be starting out with a presentation by Chris Mauro. This is Vice President of the club. He's a very good photographer as well. And so he's been talking all about eclipses and Saros cycles. Interesting. So hopefully this presentations. So we're going to get started with our presentation. And then after the presentation is over, members, please do stick around for a short business meeting. There's some interesting events coming up in the next couple of months here. So we'll talk about some of these events. So let's get started. Chris, if you want to step up to the podium here and take over. Feel free.
Sure. Thank you, Kevin.
Sure.
I don't know how good my photography is. Sometimes it works, but we'll see. Anyway, thank you. Good evening and welcome. Before I begin, I'd like to thank Dr. Mary Lou West for her support and encouragement in helping prepare some of the material. And we all, I'm sure, want to wish her good recovery from some recent surgery. So tonight we're going to talk about a number of things. So first, we're going to take a look at some recent eclipses, a couple of photographs. We'll discuss eclipse geometry, the art of predicting eclipses, some noteworthy eclipses and eclipse chasers. And then focus on the eclipses of 2023 and 2024, and some guidelines in terms of planning for viewing an eclipse. We're coming to an end of an eclipse parade in North America. Over the last 11 years, there have been 3 eclipses in North America, and there will be 2 more, one this year, one next year. If you missed the one in 2024, you're going to have to wait until 2045, August 12th, to see the next transcontinental eclipse. So this is a view of the May 20th eclipse. It was an annular eclipse out primarily in the west. And this was the view from Page, Arizona. So the photo on the left is what the moon just as it reached the lip of the sun in an attempt to try to get some of the light through the mountain ranges. And the other one was right on the center line. The moon is right in the middle of the sun. It's an annular eclipse. The origin is from Latin, annulus ring, and you can see why it's called such. This was 2017. This was a view from the foothills of the Grand Teton National Park. And you've got the eclipse up there, and you've got the Tetons in the foreground. And this was a partial eclipse that we viewed from Garrett Mountain in New Jersey. We have the astronomy group there. And that was just at dawn. It was a beautiful morning, nice low clouds. And I was able to catch a flock of Canadian geese going by. So in grade school, everybody learns the eclipse is caused because the moon gets in the way of the sun, puts a shadow on the earth, and you get a solar eclipse. The opposite is true for a lunar eclipse. The earth shadows the moon and you get a darkened moon as a result of that. So there's a terrific Scrabble word you could always use, and that's syzygy. And that basically means you have the earth and the moon and the sun in an alignment. And if somebody remembers the point scores for Scrabble, I'd like to know how many points that was. Triple words. Triple words. So in order to understand the eclipses, we have to learn first about the shadows, what constitutes the shadows. So you can see there are 3 parts, excuse me, to the shadow. First is the penumbra, which is partial shadow. The umbra, where you would have a total eclipse, and the antumbra, where you would have a annular eclipse. There is something called a hybrid eclipse, and that is where you have both a total and an annular eclipse in the same event. Basically, because the curvature of the Earth and the Moon's orbit is such that you get a total eclipse first and an annular second, or the other way around, you get an annular first and a total second. And then there's another class of hybrids that start with annular, total, and then back to annular. But one thing to understand also is the scale of the dimensions that we're looking at. So if I look at this little volleyball, it's about 8 inches in diameter, give or take. Earth's diameter is pretty close to that, so this represents the Earth. This is about a little more than 2 inches, about the diameter of the Moon. How far away do you think the Moon is from the Earth?
On that scale, maybe 30 feet.
Actually, right there, it's actually about 20. So the Moon would be here. That's about as far away as the Earth would be. So it's amazing, you think about the shadow that the sun casts, it's a very long shadow to get to the Earth. And you may ask, how about the sun? Well, the sun would be about 72 feet in diameter, in the height of like a 4-story building. And it would be about 1.25 miles out that direction, probably where the normal avenue entrance is to Montclair State. Much of what we'll talk about tonight will focus on solar eclipses, but a lot of the information can also be applied to lunar eclipses. So here's the scale I was talking about. I guess it's missing part of the picture. I'll describe it. So how do we have eclipses? Well, first thing is that the angular diameter of both the Moon and the Sun are very close. The ratio of 400 to 1 represents the fact that the Moon is 400 times less in diameter than the Sun, but it's also 400 times closer. So you end up with a situation where the angular diameter of both are relatively the same. And so when the Moon is slightly bigger, you get a total eclipse. When the Moon is slightly smaller, you get an annular eclipse. Again, it's not shown here. There are points of contact. This is important because we'll talk about that later. So first point of contact, you'll hear first point is where the Moon, where the Earth actually, where the Earth enters the penumbra. That's the first point of contact. The second point of contact is when the Earth enters the umbra. As a result, the total eclipse begins. Third point of contact is when the Earth leaves the umbra. That's when the eclipse is over. And that's probably the most dangerous time to be watching the eclipse, is at third point of contact. Because your eyes are, pupils have maybe dilated somewhat, you're watching an eclipse, and all of a sudden you get this bright light. Fourth point of contact is when the Earth leaves the penumbra. Things go back to where they were. You'll see there are parameters related to each eclipse. One of them is the magnitude, and that is the number ratio of the angular diameter of the Earth to the sun. So when, excuse me, of the moon to the sun, when the angular diameter of the moon is bigger, you'll have a 1 point something magnitude. If it's less than 1, you have an annular eclipse. The longest duration would occur when the moon is at perigee, so it's close to the Earth, so it's quite big. And the Earth is at aphelion, furthest away from the sun. At that point, it's moving slowly. It's at the slowest part of its orbital velocity. So there was something called an eclipse season. Basically, that happens because the plane of the ecliptic and the plane of the lunar orbit are not parallel. They're tilted about 5.1 degrees. So the eclipse season begins when the moon crosses one of the nodes on the orbit of where its orbit intersects the ecliptic. And there are 2 points where that happens. One is called the ascending node and the other is the descending node. So when the moon is in that position, if it happens to be in a full phase, you will get a lunar eclipse. If it happens to be in a new moon phase, you get a solar eclipse. Wait. What you have is you'll have a series of eclipses separated by approximately 6 months, slightly less. And you have, what you'll see is alternating 14 days apart or 14 and a half days apart, total eclipses, and then lunar eclipses. And the total can be partial, it can be annular, it can be a total solar eclipse. So you see that although from our point of view on, one spot on the Earth, eclipses seem very rare, they're not rare. They do happen somewhat frequently around the globe. And you can see that here's some of the recent ones. This is a great little diagram that you can get from a NASA website. And it shows for a 20-year period, all of the eclipses, both annular and total, around the globe. So this is the one that we're going to see next April, and this is the one in October. It's an annular eclipse. It runs from southern Oregon to Texas. 2024 runs from Mexico up through central U.S. up into New England and the Canadian Maritimes. So that period of time where the moon is in the nodal proximity around the either ascending or descending node, it can be in that period for about 34 days. And since the lunar orbit is 29.5 days, it is theoretically, it has happened, it is possible to have 2 full moons within that 34-day period. So you could actually end up with 2 lunar eclipses or 2 solar eclipses, with another eclipse 14 days in between. So you could end up with 3 eclipses in any one of those seasonal nodes. Now the next question is, when will eclipses occur? This has been a quest for civilizations for a long time. The earliest record of an eclipse was in China in 2100 BC. So people have always wanted to try to predict when the next eclipse is going to happen. So the Babylonians are credited with devising a method to predict eclipses. They didn't call it the Saros cycle. They just recognized that there were these cycles. Basically, it consisted of reconciling different lunar calendars. Because there are different time periods where you can get the same conditions that you would have for an eclipse. It was called the Saros cycle by Edwin Halley in 1686. So what are those conditions that have to repeat? Well, first is the moon needs to be in the same phase. So if you have a full moon, you have a lunar eclipse, and you have a new moon and a solar eclipse, the moon has to be in the same phase. So it's either going to be new to new, full to full. And that is called the Sidonic calendar. And you see that time is about 29 and a half days. The moon also needs to be in the same orbital position. So if it's at perigee or at apogee or somewhere else in the orbit, it needs to be in that same spot again. And that's determined by the animalistic calendar. And then the sun, the earth, and the moon need to be aligned around the same node. There's the ascending node and descending. And that's the draconic calendar. Let's see what happens when you kind of line them all up. Well, the synodic calendar is 29.53 days. Animalistic, 27.554. Draconic, 27.212. There's no common denominator. There is no factor that you can combine. So we lay them all out, and it turns out that it takes 6,585.321 days approximately to get to the same conditions that you had prior. And that's 18 years, 11 days, and 8 hours. And that's the measure of a Saros cycle. So if you look at the Farmer's Almanac, this was the entry for August 21st, 2017, which was the total solar eclipse. You'll see that the moon is intersecting the ascending node. That's the moon. The moon was recently at perigee, and it's within 3 days, and it's in the new moon phase. So you've got 3 of those conditions that you're looking for satisfied. This is what a Saros cycle is, a series of eclipses. And you can see in the left diagram, this is Saros 136. And this is rapidly scrolling through all of the eclipses in that series. You'll notice they start at the South Pole and they migrate northward and eventually end at the North Pole. Now at the poles, those are partial eclipses, they're not total eclipses. Now, in this case, okay, so on the left side, it shows eclipses running from June 14th, 1360 to July 30th, 2622. So a Saros cycle lasts anywhere between 12 to 15 centuries. On the right side is Saros 132, and that's the lunar eclipses. And you can see that there was no eclipse in December 11th, 2429. Actually, I should go from the top down. So starting from the top, the first eclipse partial was August 6, 1618. And the moon then went through the umbral shadow of the earth and then eventually back to the unumbral shadow, December 11th, 24, 29. There are currently 41 active lunar cycles and 40 active solar cycles. The solar cycles are numbered from 117 through 156. And 117 is last eclipse will be in 2054. So one other note, the moon is leaving the Earth approximately 3.5 centimeters per year. So eventually it will be further away, and as a result, total eclipses will cease to happen. It will only be annular eclipses. In addition, the Earth's rotation is slowing due to tidal forces. And eventually the eclipses will be longer in duration than they are today because of that. So every 18 years and 11 days and 8 hours, another eclipse in that same cycle occurs. So if we look here, we start with eclipse in 1937, and this is Saros 136. So 18 years later, 1955, we've got a very similar shaped eclipse path, so part of the same family. But there is a difference. The Earth has rotated 120 degrees. That's the 8 hours as part of the Saros cycle. And so here we have another eclipse in 1973, again in the same Saros family. Earth is rotated 120 degrees more. Finally, it comes back to the same general longitude 54 years after the 1937. Now it's 1991. As you can see, it progresses the same pattern again. In 2045, that will be the next one past this coming next year. Right? Yeah, 0.63, 0.81. So for all the boomers out there, we can remember March 7th, 1970. That was the last eclipse of the same Saros cycle 139 that we're going to see next April. And that had a path that came across southern part of the United States and not quite touching New York and parts of New England, but then eventually into the Maritimes. Yeah. So here on April 8th, we'll have that path, similar type of structure, also going up. Now, Saros is not the best way to do a prediction of an eclipse. Too many things change, lots of variables happen. One of the things is the drift that we saw of the eclipses. And part of that is caused by the fact that even though the Earth, the Moon, and the phases and everything else might be in sequence or might be the same as before, what's happened is that Earth has taken a little more time to get around to the same position that it would be in the orbit around the sun. So as a result, its axial tilt has changed. And also its distance from the sun has changed. So there are a couple of factors there that cause the drifting of the eclipses. Also, I might mention that, the orbits themselves are not smooth. The velocities change and they're variable. So, and by very small amounts, adjustments need to be made. This damage too. Okay. So a better way is to try to use some mathematical approaches to determine when the next eclipses are going to happen and where they're going to be. So we basically would start with, Kepler's laws of motion, planetary motion, and work through more advanced geometry to determine where the eclipse is going to be. These are formulas for the velocity and the period of the orbit. So a German mathematician, Friedrich Bessel, devised a method, a geometric method of determining where the shadows would fall. Primary component of this constructs a plane that is perpendicular to the path from the sun through the moon to the earth. So on this plane, shadow is represented as a circle. There's no distortion. And then mathematically translates that to the surface of the earth at that point to determine the curvature. So these Besselian elements are coordinates represented in the eclipse. So the ephemeris, the ephemeris is saved in the Bureau of Longitudes in Paris. And these are basically tables and charts of the coordinates. And the two that are used for the sun is the VSOP 87, and for the moon is the ELP 200-82. So this is what the coordinates look like. You can see you've got three-dimensional object and other components. There's also a function called the delta t, which represents the change in the Earth's rotation, change in the speed of the Earth's rotation. So there are other cycles. Saros isn't the only periodic repetition. So there was something called the SAR cycle, which is half of the SARs, 9 years, 5.5 days. And that represents a cycle where you have a total eclipse of the sun, followed by a total eclipse of the moon on the other node. And that happens in 9 years and a 5.5 day cycle. There's something called a tetrad, which is a grouping of 4 lunar eclipses. This was the one most recently in New York in 2014. And unfortunately, on that night, clouds came in and I never got the full view of the total eclipse of the moon. Didn't happen. There's something called the semester series, which is 177 days, 4 hours. And there too, the eclipses occur in alternating nodes. The one that's somewhat interesting is the INEX. It's a longer cycle, 28.94 years. And eclipses happen at alternate nodes, but this cycle maintains itself longer. Saros cycle is 12 centuries to 15 centuries. The INEX cycle is almost 20 times longer than. A good question to ask is, are there eclipses on other planets? Well, the answer is yes, there are. But first, we need to define the difference between a transit and an occultation. So, the transit is where you have an object that is whose angular diameter is smaller than the one it's shadowing and behind. So you think of a transit of Venus or a transit of Mercury, you've got a small object moving across the sun. Well, that's what happens on Mars. Moons are too small to give a total eclipse on Mars, so those moons transit. Occultation is where the moon, in this case, is bigger than the sun, so it blocks it out. Now, on some of the planets, the moon's angular diameter compared to the sun is much bigger. So, for example, in Jupiter's, there are 5 satellites that ocult the sun. Callisto is 50% larger in its angular diameter. Io is 6 times larger. And the sun's angular diameter is only 6 arc minutes. So it's quite narrow. Because Jupiter is 460 million light years, or a million years, million miles from the sun. Saturn has 7 satellites that eclipse the sun. Uranus has 12, and they repeat every 42 years because the orbits of the moons are closer to 90 degrees. So the only time they eclipse Uranus is when it reaches a solar equinox. So this is a shadow of Ariel, and there is Ariel, and you can see that here's the bands of the rotation. So it's close to, it has to be close to that 90-degree mark. Neptune has 7 satellites that will eclipse. And this is Io. And nice photograph. You can see the shadow clearly on Jupiter's surface. So let's talk a little bit about some notable eclipses. We mentioned the eclipse in China in 2137 BC. Interesting story that seems to be repeated in a lot of places, that there were these 2 astronomers that worked for the emperor named He and Ho. And they failed to predict the eclipse that happened, which was a bad omen. And so the emperor beheaded them. It's a great story. Also in the historical perspective is May 28th, 585 BC, a battle between the Persians and the Medes was halted during a solar eclipse. May 3rd, 1715, Halley predicted the duration of an eclipse in London to within 4 minutes, which was at that time quite uncommon. And he also drew this map here of the eclipse passing over the southern part of the British Isles. Two people you wouldn't necessarily associate with eclipses are Mason and Dixon, certainly well known for their survey of the border between Pennsylvania, Maryland, and Delaware. Charles Mason was an English astronomer, and he was noted for observing transits of Venus. And worked most of his life perfecting lunar tables and nautical almanacs. This was quite important to commercial shipping, other activities. Dixon had measured meridians and longitude calculations. And this I found interesting is that there is the crater Mason on the moon is named after Charles Mason. Now we got some interesting stories. This is August 21st, 1914. Sure, some of you might recall that was right after the outbreak of World War I. Prior to the beginning of the war, Irene Freiburg Campbell were on an expedition to go to Russia with the intention of supporting Einstein's theories of relativity. Freudlitz was a colleague of Einstein. He had talked to him about how to go about proving the relativity. And so he was all ready to go. Unfortunately, when he got to Russia, having a German passport bought him a ticket to jail. So he was detained with his equipment. Perrine and Campbell, not detained, continued, but to no avail. On Eclipse Day, it was overcast, so there were no observations. Now, this turned out to be very lucky for Einstein, actually, because when he was rechecking his calculations, he discovered that he had made an error. So he made an adjustment that would be useful later. And so had they taken measurements and it then proved to be wrong, might have changed history. Now, this is one of the famous eclipses on May 29th, 1919. This is the one that's known as the one that supported or proved Einstein's theory of relativity. So the war is over, everyone's back to business. Eddington was a proponent of supporting Einstein's theory. He was convinced that it was valid and that he was going to prove that. Dyson was more skeptical. So they set out to view the eclipse in 1919. Eddington went to Principe Island, close to West Africa, and Dyson went to Sovo in Brazil. The way they describe the trip is amazing, because today you get on a ship somewhere in 3 days, 4 days, you can, be hundreds of miles away, you can cross the ocean in a few days. Took him almost 3 months to go from England to Principe Island. And it took Dyson a little less time, but still quite a long time. This is a picture of the telescope equipment that they were taking with them. So you can see why this was a laborious process. So the objective was to note the star's apparent position with the effect of the sun's gravity lensing on the star behind it. That was the theory. So the sun is functioning as a gravity lens. Eddington was only able to view the last minute or two of the eclipse. It was clouded over, couldn't take any measurements. Dyson, clouds had cleared for him early in the day. He was able to take measurements, and these measurements confirmed Einstein's theory. Now, after the observation, they went back to England. Eddington made a presentation to the Royal Society, and he got a very lukewarm reception. Newton's laws had held up for almost 300 years, and the scientific community was reluctant to just immediately accept the result. In fact, they even claimed that Eddington had falsified the results. What's interesting is that Dyson was the one who took the measurements, and he was a skeptic. So he obviously checked it. Eventually, it's accepted. This was one of the more interesting eclipses that I took a look at from history. And that was January 24th, 1925, the New York City eclipse. Saturday, 9 o'clock, it was 0 degrees. And people were not deterred to go out and view this. So here's a photograph. They're holding their little viewfinders. And I believe that's the Flatiron building. And this is a shot from Central Park, northern Central Park. And what's interesting about this is, first of all, the path was almost parallel to the grid of New York City. So in an effort to really measure in detail the diameter of the moon, and you needed to know where did it intersect on that grid. So Scientific American asked for volunteers that would station themselves at different intersections in Manhattan and be able to record what they've seen, so they could determine exactly where the moon, the shadow proceeded through the city. In Montclair, the southern end of the eclipse path was right here, right, pretty much right through Montclair City. So some of the activities, there was a special train was dispatched to take viewers from Glen Ridge to the Mountain View station in Wayne. They picked them up, they stopped at Glen Ridge, stopped at a few stops along the way, picked up more passengers, brought them all up there for totality, and then brought them all back. Reports in the paper said the subways were packed going up to the Bronx. This totality was in the Bronx, not in Brooklyn. They launched a squadron of planes to follow and photograph the eclipse. Biggest squadron since World War I. They even launched a dirigible. They conducted experiments to reconfirm Einstein's calculations. They had school groups traveled to Bear Mountain, stayed overnight, and then rose early to watch the eclipse. During the eclipse, the summer triangle was visible, as were 3 other planets. Lights went on in the streets of New York, and the observation decks were packed. Hotels in the Connecticut area were charging prices that you would get for the Yale Ball. Very high. Mayor Harlan said at the time, and I love this quote, "The sun may be eclipsed, but New York, never." And if you're interested, the next eclipse that will raise New York is in 2079. We have a long way to go. Here was the path. You can see it. Raised New York, Connecticut. This was the Times report the next day. Okay. Just to wrap up, there were some other interesting eclipses. One was in 1973, which crossed Central Africa. With 7 minutes in duration, which is a pretty long eclipse. What made it interesting is the Concorde flew in the umbra for 74 minutes. July 1991. This was the famous Hawaii, Mexico eclipse. It was almost 7 minutes in duration, and with excellent viewing conditions up in Mauro, Mauna Loa, Mauna Kea areas of Hawaii. August 12th, 21st, 2017, the famous North American transcontinental eclipse had estimated about 200 million viewers. I don't know if that included people watching television. So about 200 million. And in 2024, they're expecting maybe to break that record. So get ready. You can see here are the paths. This is the one we had recently in June. That was the partial. This is the one later this year in October, and this is the one in April next year. (186 days to the annular eclipse, 363. So let's talk about planning to view an eclipse. The first thing is safety. And you need to have ISO approved equipment. So I will tell you, here are some eclipse glasses. Sure you're familiar with these. Those work pretty nicely. This also works pretty nicely too. One that you can just hold up.
Yeah, that wasn't great.
No, it wasn't.
Well, actually, you might have been okay back then because film had a lot more silver in it than it does today. Whereas today, it doesn't.
My eyes are not great.
Yeah, we definitely lost a lot, more flammable back in.
That's true, yeah.
Now, if you're using a telescope, you need something like this. This is a commercial grade solar filter. Works nice. Yeah. This, I think, well, price has probably gone up. I'm sure. I paid around $40 for it that time. Yeah.
Not today.
Yeah. But you can also make your own. These fit perfectly over a 77mm Canon camera lens. You find a PVC pipe that's slightly larger than the size you need. Put a little bit of insulating foam in there to keep it on tight. You take the eclipse material, you wrap it around, and you know, make your own.
It's solar filter material.
It's solar filter
It's
material.
specifically made. Yeah, that's the only thing you can use.
Yeah.
Stuff that's specifically made for that. You can buy a sheet of it like he's got here.
This is from Thousand Oaks. They're in California, and they sell the eclipse glasses. They sell, and as well as this filter paper, which is and it comes in a sheet. You can cut it. Yeah.
And they do it with the color, right?
Yeah, you can make it for your finder scope, your binoculars, your camera. Just make sure that it's on very secure. It's one thing you don't want to do is looking through binoculars and have these things fall off. It's not a good idea. So consider some alternates. You can do some indirect viewing of an eclipse. You see here on the left side is a colander, and you see people hold a colander on the ground, and you'll see little images of the sun. You can also interlace your fingers and create a little pinhole and see the impression on the ground. And of course, you can use a pinhole telescope to project it on a piece of white paper. Now, the plan for your eclipse viewing, number one, expect crowds. There will be, especially this one, there will be a lot of people. There are about 30 million people that just live in the path of totality alone, not counting those that can travel less than an hour to get there. It's going through some major cities. Indianapolis, Dallas, Cleveland, Buffalo. They are all in the path of totality. So it's going to be a little crowded. Get a spot early. And if you can go to the area a day or two before, scout out some areas where you might want to end up. And also make sure you have a backup plan too, in case you get there that morning at like 8 a.m. and it's already blocked off. Be careful with that. Bring some food, because where you are, you may not be able to buy it. Dress for the weather. The April weather, and depending on where you are, you can end up with a snow squall or a bright sunny day. Don't know. Drink sparingly, again, because facilities may not be available. Now, very important, expect major traffic gridlock. I was in Idaho in 2017, and even on the little farm roads, people were parked on the shoulder, so one lane could get by. It was packed even in remote areas. Mark the time for third contact. I'll talk soon. There is a phone app that you can download that will speak to you and tell you when these contact points occur. All of that. So do some research on the path and duration, probable weather. We'll talk a little bit about that in a minute. Have a backup location in the event of a change in weather. I like to think of it as you locate yourself somewhere and you can go in one of three directions based on the forecast. Plan for activities other than the eclipse. This is an interesting one because there's some kind of interesting cities that you're going to be near. I know in Cleveland, at the Rock and Roll Hall of Fame, they're planning on having some event. I can only picture them playing Dark Side of the Moon or Black Hole Sun or, what was that other eclipse? A total eclipse of the sun.
Okay.
The other one. Okay. If you plan on doing any imaging, make sure you know your equipment. You don't want to be fumbling around, trying to figure out what to do when you've got a little time clock going there, 3 minutes, 40 seconds, and you've got to take some photographs. Okay, so we talked a little bit about the filters. Use appropriate filters. Make sure your batteries are charged. It's a little checklist in your mind. Use new memory cards. I mean, you don't want to fill up a card and all of a sudden you can't take any more pictures. Use a manual focus. This is important because autofocus isn't going to work when you're pointing your camera up at the sun. That's not going to work. So you want to use manual focus. Focus at infinity and maybe slightly back off. But use it in manual mode. Use manual exposure as well. Take a meter read and adjust it because you're going to probably want to bracket the exposures. Use a tripod and a remote shutter. Do not use the camera HDR. I made that mistake. I'm disappointed I did. I thought it was going to work out nicely. Pictures were not that great. Too much banding, too many things going on. There's other software you can buy that will do a better job of stacking and making an HDR picture. Bracket your shots. One fellow that I read recommends 9 in the bracket. There's others that talk about 36. So depending on the equipment you have and your patients, you can figure that out. One other thing, do watch your equipment. There are people around. You don't want to be leaving things on a tripod and walking too far away. It'd be great if you can go with other people. I think that's helpful. Have some people with you. Okay. So what do you watch for? Well, first thing, note the points of contact, especially the third. Watch for the projection of the eclipse on the ground around trees. This is leaves make little pinholes. Watch for the shadow bands. They occur just before totality and just after totality. These are atmospheric ripples that you can see. There's a video on YouTube that shows these ripples running across a white sheet that someone had laid on the ground. It happens just before totality. Look for Bailey's beads. This is the sun peeking through the lunar mountains just before totality. Look for the diamond ring effect. It's unmistakable. See this bright area around where the intersection of the moon is with the sun. Look for the corona. If you have a telescope, look for prominences. You'll see them. You can look for planets. Mercury and Venus should be visible. And look for the background stars and constellations. It should be, I used a planisphere here, and sort of equivalent to December night around 9 o'clock. So what you'll be able to see is certainly be able to see Orion, probably Taurus, maybe the Pleiades, and if we're lucky, maybe a square of Pegasus, but that might be a little hard to find. But certainly Orion and Taurus should be able to see. Maybe Gemini, maybe. Observe the surroundings. Don't just get wrapped up in the eclipse itself, which can be preoccupying. Look at the other sounds, wildlife. Look at the horizon. It's like sunset around the horizon, 360 degrees. Look at other people. See what they're doing. I'm sure many of you have been to eclipses, but those who haven't, when the eclipse starts, actually begins the totality, you get a huge cheer from the crowd. It's a great feeling. It's part of a community thing. Have fun and enjoy. Here's a couple of photographs that I took in 2017. This is one of Bailey's beads. And you can see Regulus in the lower left. You were able to see Leo pretty clearly. So this is the path of the annular eclipse in October. We're not going to talk much about that. Best viewing place would probably be around Texas or Albuquerque, or somewhere in between those two, because the weather will be reasonable. That's going to be the big issue for April next year, is the weather. This is a map showing the potential cloud cover in April along the path of the eclipse. So you can see here in the Texas area, it's not, in some areas it's not quite 50%, but in a lot of areas it's around 50%. And that extends upward and eventually goes up to the yellow, orangish, 60, 70%. We're at 60, 70. And eventually, as you get further up into the northern reaches of New York State, northern New England, and maybe Maritimes, it's 80, maybe 90% chance of cloud. I don't know if that means that, if it's 90%, does that mean that one day out of the 10 is okay? Or does that mean 90% of the day is cloudy and only 10% sunny? I'm not sure. But whatever it is, it doesn't look great. It's going to be a challenge to find, a good spot. There is a website, I'll point it out to Jay Anderson. He's a meteorologist and Eclipse liker, and he's written a number of pages on the climate and projections for weather. Points out two things that I thought were interesting. He said in this Texas region, he said north of San Antonio, toward Austin, is the foothills begin. They call it the hill country. And he said that you see anything west of there is more in this maybe 30% range. So he said that's a good area to look at. The elevation is going to help. Any moisture coming up from the Gulf, it's going to get blocked a little bit by the raise in elevation. He also pointed out something that was interesting, was that up here, let's say Buffalo and Cleveland, again, which are pretty much on the center line, the influence of the Great Lakes is a positive effect. If you get a northerly breeze over the water of the Great Lakes, it will keep the clouds below those cities. Also included is Rochester in that discussion. So it's something to maybe consider. If you're going to take a shot. Problem is, if we get weather like we've had, and like over the last couple of weeks, we see all the tornadoes and storms coming through. I mean, it's going to be really challenging to find a place to deal with it. Even a day like today here started out kind of nice, but then it really clouded over. In the Texas area, the eclipse is going to occur around 2 p.m. Maybe slightly earlier. The duration is a little longer. It's about 4 minutes, maybe 4 minutes, 10 seconds. Up toward Cleveland to Buffalo, it's 3:15 p.m. and it's about 3 minutes and 40 seconds. 2 minutes, 30 seconds duration. So he also includes this in his website, and this I think is a more positive way to look at it. Rather than looking at the percentage of the chance of being cloudy, how about the percentage of it being sunny? Which is much more positive. Okay. So you can see a couple of areas here that where you got a couple of spikes, like one here, north of Little Rock, which I was kind of surprised where that came from. But that's got over a 70% chance of sunny at some point. Look across, here's Rochester, which also has an interesting, number there. So a little slightly over 60%. This might support his discussion that the northerly winds over the Great Lakes does influence that microclimate. It does give you a chance of having some sun. Okay, so there are a number of websites that are available that will give you some really great information. I have a list of them printed here if you want to take a copy. So the first one is the NASA site. There's the eclipse.gsfc.nasa.gov. They've cataloged over 5,000 eclipses, over 5,000 years, excuse me. 61,841 months, 11,898 eclipses. And they give you all the parameters and where the impact was, where the eclipse occurred. The eclipse calculations were done by Fred Espenak. He's a NASA astrophysicist. Now, the site will redirect you to solarsystem.nasa.gov, but either one give you good information. The next one, dateandtime.com, has interactive maps of the eclipse path and shows you a lot of other things. Describes lunar calendars, months of different types, so it's very informative. Jay Anderson's site is Eclipsophile, and it's spelled without the E at the end of eclipse. It's Eclipsophile. And he describes the climatology and the weather along the path. Then Fred Espenak has his own websites, Mr. Eclipse and eclipsewise.com. And this runs the gamut of information, both beginners and experienced watchers. He has a list of vendors that he has approved for eclipse glasses and so on. He gives how-tos on how to photograph the eclipse. Or these are some tips and ideas. Next one is also quite interesting, and that's the eclipse. That one. So the next one here is eclipse2024.org. Dan McGlowan, he's put together a eclipse simulation. So you have the path of the eclipse. You can click on a spot, and a little window opens that will show you a simulation of what the eclipse will look like at that point. It gives you the longitude and latitude, and things like that nature as well. Then there's the GreatAmericanEclipse.com, which again provides more information. Solar eclipse timer, very important. There's a phone app. You can get it from your Google phone app store. It will tell you when first contact, second contact, and when third contact is occurring. It will tell you, direct you to look for different things like Bailey's beads, shadow bands, look for different planets. It's well worth looking into that. Next one is myscienceshop.com. Michael Zeller and Michael Package. I've read the Eclipse Guide. You know, recognize they're writers for both Astronomy Magazine and Sky Telescope. And then the HDR Sol. Photomax Pro is the stacking software. And from what I haven't used it, but from what I've seen from the demonstration, it works a lot better than some of the other stacking software that's around. They have a plug-in for Lightroom, and they have a standalone version. Standalone version is about $99. The plug-in for Lightroom is about $49. That's hope that helps.
Where are you going?
I don't know yet.
Oh,
I was thinking of Cleveland.
Okay.
There's a spot right off the lake, Avon. It's called Avon Lake. It's right on the center line. So I was thinking about that.
It goes through the UC area.
it does. But that's also for the Adirondack retreat. It does. Unfortunately, there are two things that happened in April in that part of the Adirondacks. Clouds and snow. And snow about that deep. Yep, but otherwise, yes, you're right. It's right through the AR.
If anyone wants a list of those websites, I have a copy here. You can just pick it up. And if you'd like the whole presentation, I can email it to you.
Oh, yeah.
Thank you.
Any other questions for Chris?
Well, one question, I might be more of a question for you, Kevin, about chasing, you mentioned before about sending planes up to chase in 1920s to chase the eclipse.
Yeah.
Back then, it'd been very hard to do because planes can't get up the speed of the rotation of the earth, right?
Right. Oh, not even close.
Now you
No,
know.
not even close.
But now you can do it easily, and many people have.
You have to go supersonic though, right? You need a super system.
Well, I mean, you don't necessarily have to keep up with it, as long as you're moving pretty fast. You can extend your view of the eclipse by quite a bit. And I know that people like Joe Rayo, who's a meteorologist up in Westchester County, he's a longtime amateur astronomer, and he's done it with groups of people and hired a plane and they followed the path of an eclipse, and you can get a pretty nice view.
But to keep up with, say, you really want to keep up with, you need supersonic speed.
Yeah.
Oh,
you really-
definitely. The speed,
Yeah, it's 1,100 miles an hour.
yeah,
So it's the
Right.
speed of the earth.
right. About 1100, and that's,
And your average jet is only going 5.
Right, 500, so you can extend it, you can extend your
But then,
view.
when you're flying to the Concord, that could do it.
Yeah,
So,
but
But eventually the eclipse speeds up as it tails off. You'll notice that it turns more elliptical, the shadow pattern.
Right.
It's traveling faster. It's traveling closer to 2,000 miles an hour.
Isn't that usually around sunrise, sunset?
Yeah. And when it hits that part of the earth where the curvature starts to really affect it. It's slower as you're nearer the equator. And so the Concorde, even though that is probably what Mach 1.5.
it's feel like those were there, like,
Yeah. About 1.5. depending on-
Yeah, 74 minutes.
That's impressive.
Pretty good, over an hour. Not bad.
any other questions? Yes. No?
Not such a question, but incidentally, over upstate New York, this April wave was clear.
Or was it?
Okay, yeah.
This one it just passed was clear. I hope that doesn't mean that we had our one clear one and now they're gonna get. But we'll see.
But, in October, when we get the solar eclipse, the annular solar eclipse, which will be partial here, I don't remember what the percentage is, but it's a pretty good chunk, it's like maybe 30%, something like that. You get a pretty good, decent partial eclipse. And so that's a great practice session, if you want to practice at home, just get all your equipment ready as if you were setting up for 2024 and use all the same equipment and get it all set up and set it up in your backyard or wherever you want to get a good view of the sky and try it out. So if you're going to get some blurry, out of focus eclipse or eclipse pictures, now's the time to do it before the actual big event comes up in 2024. So it's a good practice session.
Yeah, so this is
Also like taking pictures of the full moon too. Gives you a good idea of what the size of the sun is going to be during the eclipse, so you can kind of practice.
This is the coverage map, so it looks like
Right.
it's, looks like
How
it's
much?
almost 40%.
Oh, okay, so maybe a little bit
35.
more than, yeah, so it's a good chunk, it's a good chunk of, the sun is going to be covered in October for this particular eclipse.
We know what day of the week that is?
I don't recall, yeah, check it out, what day of the week is it?
I'm sure we asked about so much.
Yeah, I mean, we should think about that.
Saturday.
Is
Yeah.
it Saturday? Okay, well, that's nice. So yeah, it's a Saturday, you know, we can think about doing some kind of event locally for that if people are not traveling.
Jenny
I
Jones
mean,
probably doing it.
Jimmy Jump would probably do one. I mean, like I could host one at County College of Morris, or I could do one here at Montclair State. You know. Yeah. Yeah, so yeah, we should think about that, you know, people are not gonna travel out to, say, Texas or New Mexico for this eclipse. They wanna do something locally, both club members and the public. Think about that, you know.
Well, we could all do the NJAG event at UAC. That's another thought. We'll have
Yeah,
the solar telescope.
the only problem with Jenny Jump is that, you know, you don't get him about 100 calls.
Right.
That's about it, you know. We have to, you know, they had the 2017, I don't quite know how many people they got up there for 2017, but we could ask them about what their capacity was for that, but,
Right.
you know, it's, it can be kind of tight up there.
Right,
you know, in terms of space.
Right. We could do $10.
So, okay, thank you, Chris, thank you very much for the
Thanks,
nice
Chris.
presentation there.